Hello everyone. So this is the next video on real analysis. We will be discussing multivariable analysis of vector point functions. As of now, we were studying f from Rm to R, that is scalar valued function. But now we will study vector valued function. So to begin with, let's start with this example. F of x comma y equals to x square plus y square comma x square minus y square. To begin with, as we said, we start with r square to r square. So r square to r square ಅಂದರೆ ಇಲ್ಲಿ ಎರಡು ವೇರಿಯೇಬಲ್ ಇರಬೇಕು ನೋಡಿ, x, y. ಇಲ್ಲೂ ಎರಡು ಇರಬೇಕು, 1, 2. Then we say it's a function from r square to r square. So when this function is particularly continuous and when this function will be differentiable. Very simple, ತುಂಬ ಸುಲಭ ನೋಡಿ. You just think about this first coordinate. Whether it is continuous, being a polynomial function, this is continuous. Think about the second coordinate, whether this is continuous, being a polynomial, this is also continuous, as well as this is, both are continuous and both are differentiable. So you can say coordinate wise agbeku. Each coordinate must be continuous. Then we say the function f is continuous. If each coordinate is differentiable, we say that it is differentiable. Idea is clear? Yes. ಅದೇ ಹೇಳಿದ್ದೀನಿ ಇಲ್ಲಿ, x square plus y square and x square minus y square are differentiable and continuous. So now if we try to generalize this for Rn to Rm, then x bar ಅಂದರೆ ಇಲ್ಲಿ n ಇರಬೇಕು. x bar is x bar ಅಂತ ಯಾಕೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಅಂದರೆ it looks like this. x bar is precisely x1, x2, xn ಹಿಂಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ n ಎಲಿಮೆಂಟ್ಸ್ ಇರಬೇಕು, coordinates. So if you map this here, you will have m such elements. Each is a function. So if they are individually continuous, coordinate wise, this must be continuous, this must be continuous, this must be continuous, then we say f is continuous. Similarly, if each is differentiable, we say f is differentiable. So what is this f1? f1 andre, f1 is a function from Rn to R. It's a scalar valued function. ನೋಡಿ ಇಲ್ಲೂ ಅಷ್ಟೇ. ಇಫ್ ಯು ಆರ್ ಗಿವಿಂಗ್ ಲೆಟರ್ಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಫ್ ಆಫ್ 1, 2 ಏನಾಗುತ್ತೆ ಆಗೋದು? ಸೊ ಯು ವಿಲ್ ಗೆಟ್ 1 + 4, 5 ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ 1 - 4, -3 ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ದಿಸ್ ಈಸ್ ಎ ಸ್ಕೇಲಾರ್, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಎ ಸ್ಕೇಲಾರ್. ಸೊ ದಟ್ಸ್ ವಾಟ್ ಆರ್ ಎನ್ ಟು ಆರ್, ಇಟ್ ಮಸ್ಟ್ ಬಿ ಎ ಸ್ಕೇಲಾರ್. ಈಚ್ ಫೆಲೋ ಈಸ್ ಎ ಸ್ಕೇಲಾರ್ ಇಯರ್. ಇಟ್ಸ್ ಎ ಫಂಕ್ಷನ್, ಬಟ್ ಇಫ್ ಯು ಪ್ಲಗ್ ಇನ್ ದ ವ್ಯಾಲ್ಯೂ ಅಟ್ x1, x2, xn, or else let us assume it is some a1, a2, an. At that point, this fellow will be a scalar valued function. If you are not evaluating at a single point, it just will look like some function. General ಆಗಿ ಬರೆದ್ರೆ ಹಿಂಗಿರುತ್ತೆ. If you are considering at one point, you will get a scalar. That is the meaning of this. Then when we say that this function is continuous, we say that the function is continuous if each member is continuous, and we say that it is differentiable if each member is differentiable. Adu helidini. So the example what we took, x square plus y square, x square minus y square, is continuous as well as differentiable. Artha agutta adu? If we move on and on, nodi, this is, we already know how to define the differentiability from r square to r. We said that a function f from r square to r is differentiable if f of a plus h plus b plus k minus f of a comma b. Andre this is the incremented value minus the value. Difference must be there. Change, some change must be there. That's why idan increment ಮಾಡಿ minus this. So there is some change. Differentiation means that there should be some change. That's why this fellow equals to ah plus bk plus square root of h square plus k square into error function, where a is the partial derivative at x, partial derivative along x, fx at ab. B is the partial derivative with respect to y along a comma b. If error function goes to 0, then we say that the function was differentiable. How to write that in this way? Just keep error function here and keep all these fellows to the left. So you will get f of a plus h minus b plus comma b plus k minus f of ab. That is the change. What else you are seeing from the function? minus AH plus BK equals to limit of h comma k tending to 0 comma 0 E of h comma k. Here I have h square plus k square. So this you can write it in the matrix form. You can write it in the matrix form, that is you write as it is. ಇದನ್ನೆಲ್ಲ ಹಂಗೆ ಬರ್ಕೊಳ್ಳಿ. Minus AH plus BK. ನೋಡಿ ಅದನ್ನ ABHK. This is matrix. ABHK. If you just simplify this, you will get back the same. As limit as h comma k tends to 0, this error function is that it must tends to 0. Then we say that f is differentiable. And we are doing it for r square to r. Now, the same thing can be written by using linear transformation. This is matrix form. Linear transformation form andre enilla, you just take h tends to 0, h na ಒಂದು some vector ಅನ್ಕೊಳ್ಳಿ, ಅಥವಾ it's a h is some h comma k, ಅಥವಾ ಇಲ್ಲಿ h1 h2 ಅಂತ ಹೇಳಿದೀನಿ ವೆಕ್ಟರ್ ಅನ್ನೋ ಥರ. So it's a vector h1 to h2. F of x naught plus h minus f of x naught. There is some change. Incremented value minus some value. Minus this transformation, because any matrix is a transformation and any linear transformation is a matrix. By that magnitude of that vector, that must tends to 0. ಇದನ್ನು ನಾವು linear transformation form or else transformation form ಅಂತ ಕರಿತೀವಿ. This is the matrix form. You can extend the same idea from, instead of 2, you can extend for Rn to R. It's a scalar valued function of n variables. So if you are extending the same idea, nothing will change here. Just you need to change from 2 vectors to n vectors, that's all. Your h was saying just h1, h2. Here you need to say h1, h2 up to hn. You must entertain n members. Same idea, instead of 2 members, you entertain n members. Here only 2 members are there, you entertain n members. Minus only 2 were there, you entertain n. Only 2 are here, you entertain n. Same idea. By magnitude is h1 square, h2 square, hn square. That must tends to 0. This is a matrix form antivi, since matrix is involved. But can be written in linear transformation form. This is the linear transformation. Incremented value minus the value at that point minus t of h. What is this t of h? T of h is fx1 at x naught bar, fx2 at x naught bar, fxn at x naught bar. So this is the linear transformation form for the differentiability. This you can extend. See, we started from r square to r, and we are extending the same idea for rn to r. The next natural question is, can we think of rm to rn in the matrix way or else any other transformation way? Vector valued function of vectors. Can we think in that way? See, that is done by this. If you have Rn to Rm, where m is greater than or equals to 2, it's a vector valued function. It is said to be differentiable at n points must be there. Domainal ಎಷ್ಟಿದೆ ಅಷ್ಟಿರಬೇಕು. If and only if there exist partial derivatives aij ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. That is this. If you have n to m, where m is greater than or equals to 2, then the same idea. Here you will say h1, h2, hn tends to 0. Here you have n entries. Here also you have n entries. But here the matrix, what else you are seeing? Last time you had only this a1, a2, an ittu ashte. It depends on this. And what is the order of this? There are 1 row, n columns. That's what transformation andre nodi. If I can write this as Rn to R, the linear transformation T will be R to Rn. Athwa matrix will be, matrix anbidi, T is a matrix. The matrix will look like ulta hogಬೇಕು 1 to n, 1 cross n matrix. So ಇಲ್ಲಿ ಅದಕ್ಕೆ 1 cross n matrix ಇದೆ. But here, if you are coming from Rn to Rm, then the matrix will be m ಕ್ರಾಸ್ n ಉಲ್ಟಾ ಹೋಗ್ಬೇಕು, m ಕ್ರಾಸ್ n ಅಷ್ಟಿರುತ್ತೆ, m ಕ್ರಾಸ್ n, n ಕ್ರಾಸ್ 1. This is h1 square plus h2 square, hn square is there. This must tends to 0. That must be, if you are once you are limiting it, it must tends to 0. Then we say that f is differentiable. The same thing can be identified in the transformation form as we observed. Same idea. Moving on, we have one question here. Check the derivative, like whether it exists at 1 comma 2, and the given function is this. So we have the formula actually. It is 1 plus h1, 2 plus h2 minus, this is incremented value minus the exact value, t of h1, h2. T is the transformation. What is this transformation? Transformation is a matrix, as we said. Nodi, simple ide. You say this is f1, idanna f1 ankolra. This you say this is f2. f1, f2. ಏನು ಮಾಡಿ ಅಂದರೆ ಯು ಸೇ f1x, ಇಲ್ಲಿ f1y, ಇದು ಚೇಂಜ್ ಮಾಡಬಾರ್ದು. ಯು ಟೇಕ್ ಕನ್ಸಿಡರ್ f1, ಯು ಡಿಫರೆನ್ಷಿಯೇಟ್ ಪಾರ್ಷಿಯಲಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು x, and you differentiate f1 partially with respect to y. Then consider f2, that is with respect to x, f2y. That is your at, what is the point? Yav point alli keltano adu at 1 comma 2. That will be your matrix T. So if you are finding f1x, idu f1, this is f2. Partially madidre idu 2x aito. f1y 2y aito. f2x 2x. If I differentiate partially, it is minus 2y at 1 comma 2. ನೀವು ಮಾಡಿದ್ದೆ ಆದರೆ 1 ಮತ್ತು 2 ಪ್ಲಗ್ ಮಾಡಿದ್ರೆ ಇದಕ್ಕೆ 2 4 ಆಗುತ್ತೆ. ಇದು 2, ಇದು minus 4, ಅದಿದೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಂಟು h1 h2. ಸೊ ದಿಸ್ ಮಸ್ಟ್ ಟೆಂಡ್ಸ್ ಟು 0. 0ಗೆ ಟೆಂಡ್ ಆಗುತ್ತಾ ನೋಡಿ. ಸಿ ಹಿಯರ್ ಲಿಮಿಟ್ ಆಸ್ h1 comma h2 is tending to 0 comma 0. If h1 is tending to 0 and h2 is tending to 0, this is f of 1, as good as saying f of 1 comma 2. ಹೌದಾ? As h1 tends to 0, h2 tends to 0, this is f of 1 comma 2 minus f of 1 comma 2. ಇದು 0 ಆಗಿಬಿಡುತ್ತೆ, ಬಟ್ ಇದು 0 ಆಗಬೇಕಲ್ಲ. So if h1 and h2 tends to 0, then definitely this matrix also tends to 0 by h1 square plus h2 square. This will be 0. So f is differentiable at 1 comma 2. ಅಲ್ಲಿ ಕೇಳೋದು ಅದೇ ರೀತಿ, whether the derivative exists at 1 comma 2, ಅಥವಾ find the matrix. ಅದು ನೆಕ್ಸ್ಟ್ ಮಾಡೋಣ, we will discuss that. Find the derivative matrix. Okay. Then we have one theorem. This theorem is somewhere, it connects with the functional analysis or else the linear transformation in what you study in vector spaces or else linear algebra. Nodi, T is a transformation from Rn to Rm. If this transformation is linear, then no need to check the continuity. T will be continuous and T is differentiable. And what is the derivative? Derivative is nothing but the same linear transformation. Differentiation ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಅದೇ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾನೆ. For example, I have one problem here. L of x comma y equals to x comma minus y. Whether this is a linear transformation? This is a linear transformation. So it is continuous, it is differentiable. What is the derivative? Derivative will be x comma minus y. Derivative will be x comma minus y. Idea is clear? ಅದೇ ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಅಂತ. Again, if f of x comma y equals to x plus y comma x minus y, compute the derivative at 1 comma 2. Derivative ಅಂದರೆ, see, if I want to find the derivative dy by dx of some function, ನೋಡಿ, alpha f1 plus beta f2, where alpha beta are scalars. ಹೇಗೆ ಕಾಣುತ್ತಿದೋ? ಆಲ್ಫಾ ಇಂಟು ಡಿ ಬೈ ಡಿ ಎಕ್ಸ್ ಆಫ್ f1 ಕಾನ್ಸ್ಟೆಂಟ್ ಹೊರಗಡೆ ತಗೋಬೇಕು, ಪ್ಲಸ್ ಬೀಟಾ ಇಂಟು ಡಿ ಬೈ ಡಿ ಎಕ್ಸ್ ಆಫ್ f2. This is nothing but the property of your linear transformation. So this transformation is linear, the derivative is linear. If you have a linear transformation is nothing but a matrix. A matrix is nothing but a linear transformation. ಹೌದಾ? Suppose if I have a linear transformation T from R square to R3, then the linear transformation would be, the matrix would be 3 cross 2. Suppose if you have a matrix of order 3 cross 2, it's a linear transformation from R square to R cube. Linear algebra dalli ಮಾಡೋಣ ಇದು. We'll discuss these things. But as of now, ಇದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, T is equals to f1x, f1y, f2x, f2y. This is the transformation matrix, derivative matrix. ಅರ್ಥ ಆಗುತ್ತಾ? ಬಟ್ ಅಟ್ ದಟ್ ಗಿವನ್ ಪಾಯಿಂಟ್ ಹೇಳಿದ್ದಾರೆ f1x ಏನಾಗುತ್ತೆ ನೋಡಿ, ಇದು 1, this is f1 and this is f2. Differentiate with respect to x and with respect to y. Idu with respect to x and with respect to y. You will get this. So this is the derivative matrix. And what is the derivative? That is into xy. ಇಲ್ಲಿ ಮಾಡಿದ್ವಿ ನೋಡಿ, into that. ಅದನ್ನು ಮಾಡ್ಕೋಬೇಕು ಅಂತ. If you find it, you will get x plus y, x minus y. ಅಂದ್ರೆ ಅದೇ ಬರುತ್ತೆ ನಿಮಗೆ. ಆನ್ಸರ್ ಏನು ಬಂದಿತ್ತೋ, ಕ್ವಶನ್ ಏನಿತ್ತು ಅದೇ ಆನ್ಸರ್ ಬರುತ್ತೆ. ವೈ? ಬಿಕಾಸ್ ಇಟ್ಸ್ ಎ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್. ಅದೇ ಇಲ್ಲಿ ಹೇಳಿರೋದು. ಇಫ್ ಯು ಹ್ಯಾವ್ ಎ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್, ದೆನ್ ದ ಡಿರೈವೇಟಿವ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಸೇಮ್ ಥಿಂಗ್. ವಾಟ್ ಎವರ್ ಯುವರ್ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಈಸ್ ದಟ್ ಈಸ್ ದ ಥಿಂಗ್. ಬಟ್ ನೆವರ್ ಎವರ್ ಯು ಶುಡ್ ಡೂ ದಿಸ್. ಈ ಡಿರೈವೇಟಿವ್ ಕೇಳ್ದ ಅಂದ ತಕ್ಷಣ ಯು ಕೆನಾಟ್ ರೈಟ್ ಇಟ್ ಆಸ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ 1, ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ 1. ಹಿಂಗೆ ಮಾಡೋಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ದಟ್ ಈಸ್ ನಾಟ್ ದಿ ಕರೆಕ್ಟ್ ವೇ. Next, if you are coming for the third problem, f of x comma y equals to x square minus comma y square plus sin x is there. Find the linear transformation representing the derivative of f at x comma y. Nodi, if you want to find the linear transformation representing the derivative, so it is nothing but the same matrix. If you find it, you will get 2x 0 cos x 2y. It's a linear transformation. But you cannot say cos x is there, so it is not linear. You will ask at some point. For example, if you ask at 0 comma pi by 2, plug in 0. 0 is, if you plug in 0 for x, this will be 0, 0 and cos 0 is 1. And for pi by 2, y should be pi by 2. No y here, only this term as y. So 2 into pi by 2, you will get pi. So this is the linear transformation. Idea is clear? Thank you. We will continue in the next video with the inverse function theorem and few properties of that. Thank you.